Hey everyone, in this video we're going to be talking about something called the unit circle. This is from section 6.2 in your book. The unit circle is something that in the past I've had some of my classes memorize the unit circle. It's basically a circle with a radius of 1, and it's going to tell us all kinds of information about the degrees, the radians of sine, cosine, and tangent functions, and actually also the other three functions, which maybe you haven't heard of yet, but are cosecant, secant, and cotangent. So at any rate, I have had students memorize this in the past. Our current format of the class isn't really going to allow us to do that. However, you do need to be very familiar with the circle, and we're going to use it for several assignments. So like I said, this unit circle has a radius of 1. I'm not going to go into all of the math on how this is calculated, but again, you do need to memorize this to some extent. I can't test you on the memorization, but you need to basically memorize how to use this circle. All right, so let's go ahead and get started. We're going to put 3 types of information on this. We're going to put degrees, radians, and then also a coordinate pair. So let's start with the degrees because that's what you're most familiar with. And I'm going to be writing these on the inside of the circle here. So when we start a circle here at this point, the degree measurement would be 0 degrees. And then we could fill in a lot of the other ones. Up here at the quarter mark here would be 90 degrees. This would be a 90-degree angle. Over here would be 180 degrees. Down here would be 270 degrees. And then back all the way around the circle would be 360 degrees. So that should be fairly simple. In the middle of these, sort of the quarter mark of these, I guess you could say halfway between the quarter, this would be 45 degrees, right? Over here, we would have 135 degrees. Basically, I'm just dividing these in half. Each of these quarters goes by 90, so halfway between that would be adding 45 degrees. So over here would be 225 degrees. Get up to 270. Add 45 to 270, we get 315 degrees. Okay. From there, these lines in between, just before the 45, is actually 30 degrees. And then if we were to go to the next one, we're going to add 30 to that, so we get 60 degrees. So you can think of these as 30 plus 30 plus 30 to get 90. Add another 30, we get 120. Add another 30 to that, we get 150 degrees. Add another 30 to that, we get 180. Add another 30 to that, we get 210. Add another 30 to that, we get 240. Add another 30, we get 270. Add another 30, we get 300. Another 30, we get 330. And another 30, we get 360. So all the middle ones are adding 45 to go all the way around, and then the other ones are adding 30, 30, 30. So you can start to see the pattern there. And you could see how you could start to complete this on your own once you identify the patterns. So that's all the degrees. The next up is going to be radians. For the radians, we actually did learn how to convert these from degrees to radians. We're not going to want to do that for all of these. You could certainly do it. But generally, you just memorize the equivalent for these. So the first one, 30 degrees, that is equivalent to pi over 6 radians. So let me write that in a different color here. Let's go with blue. All right, so this is pi over 6 in radians. 45 degrees is equivalent to pi over 4. 60 degrees is equivalent to pi over 3. And 90 degrees is equivalent to pi over 2. All right, so you'll start to see a pattern with this as well. We could definitely figure out the other equivalents to like 180 degrees. That's halfway around the circle. That's equivalent to just pi. And down here at 270 degrees, that's 3 pi over 2. It's like 3/2 pi. And then all the way around the circle, we would be at 2 pi. So all the way around a circle is 2 pi radians. Also would be starting at 0 radians. Okay. Now you'll start to see a pattern here. Just like before for the middle ones of these, we added 45. For the middle ones of these, we're adding pi over 4. Because we go from 0 to pi over 4. Another pi over 4, we get pi over 2, because that's like 2 pi over 4. Okay, so the middle of the next one is going to occur at 3 pi over 4. And then we add another pi over 4, we get 4 pi over 4, which is pi. The next one will be 5 pi over 4. Another pi over 4, we get 6 pi over 4. That reduces to 3 pi over 2. So then it's 7 pi over 4, this middle, and then 8 pi over 4, which is equivalent to 2 pi. And now the other ones, just like before how we added 30 degrees, in this case we're going to be adding pi over 6 because that's equivalent to 30 degrees. So we got 1 pi over 6 here. The next one is 2 pi over 6, which reduces to pi over 3. Then it's 3 pi over 6, which reduces to pi over 2. So then it's 4 pi over 6 here. 4 pi over 6 reduces to 2 pi over 3. It was, I think, 4 pi over 6. The next one will be 5 pi over 6. That doesn't reduce. Then we have 6 pi over 6, which is just pi. Then we have 7 pi over 6. Next one will be 8 pi over 6. But 8 pi over 6 reduces to 4 pi over 3. Then we got 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6, that reduces to 5 pi over 3. And then 11 pi over 6 can't be reduced. And then 12 pi over 6, which is 2 pi. So again, you can start to identify the patterns here. You can see how you could complete this on your own. All right, the next thing is going to be pretty important. This is going to be the coordinate pairs. Okay. So that's what's going to go out here. So if you think of this as just being, again, a circle, the middle of this circle is 0.00 here, 0, 0. And this, if this has a radius of 1, think of this line here, the horizontal one, as the x-axis. Okay, so this coordinate pair out here would be 1 in the x and 0 in the y. Up at the top, that would be 0 in the x and 1 in the y. Over here, that's going to be negative 1 in the x and 0 in the y. And down here is 0 in the x and negative 1 in the y. So those are the easy coordinate pairs. Because again, think about the center of this circle being on the origin. Okay, now it gets a little dicey from here. This is maybe the hardest part of the memorization, is these other coordinate pairs. The first one, how you would actually figure these out would be using special right triangles. And I'm not going to go too in depth on that. If we're in class, maybe I would, but I'm not going to go too in depth into getting how you come up with these. But just knowing these coordinate pairs, the first one is radical 3 over 2, comma 1/2. The next one is going to be radical 2 over 2, comma radical 2 over 2. And the next one, we're just going to switch to the first one. We're just going to switch those coordinates. There's going to be 1/2 in the x and radical 3 over 2 in the y. Okay. Now, once you memorize one quadrant of this, it actually isn't too bad because all of the other quadrants, so this is our first quadrant, right? Quadrant 1. All of the other quadrants are the same. The only thing that's going to change is the signs, whether they be minus or plus, because we're in the second quadrant. So in the second quadrant, whereas the first quadrant, x and y were both positive, in the second quadrant, all the x's are negative. There's a negative x direction, but still in the positive y. So all these x's will turn to negatives, but the y's are still positive because negative x, positive y. And what we're going to do is kind of think of these like reference angles. This first one actually matches with the last one over here. You can see that they're kind of the same distance from both the x and the y axis. The reference angles on these, if you remember when we did the reference angles, how you just draw the line straight down. Kind of, you can think of those sort of as being sort of equivalent in that they're the same distance from the two axes, right? So you can see this is the same distance from here to here, right, as this one is. See how they're the same distance from the y-axis, and then they're also the same distance if we were to draw a line straight down to the x-axis. From both of them be the same distance. So the only thing that changes is the sign. Put this here. So this first one is just going to be negative a half, and then still positive, radical 3 over 2. The second one, the quarter marks are the same, but again, the only thing that changes is the x-coordinate. So it's just negative radical 2 over 2, comma radical 2 over 2. And then if you'll notice, the next one is the same distance from the x and the y-axis as the first one. It's going to be like negative radical 3 over 2, comma 1/2. Fix this real quick. Okay, and then we keep the same theme going down. So then we look at this one, the last one here, as the same as the next first one. You can see how they're the same distance from the x and the y, except in this quadrant, the third quadrant, both are going to be negative. Both negative x and negative y. So this is just going to become negative radical 3 over 2, comma negative a half. The next one's going to be negative radical 2 over 2, comma negative radical 2 over 2. And then we've got negative 1/2, comma negative radical 3 over 2. And then our last quadrant, quadrant 4, we can just look at quadrant 3. Again, they match up. So the last one matches the first one of this one. We just have to think about, is x or y positive? And in quadrant 4, the x's are positive, the y's are still negative. So it's going to be positive a half, negative radical 3 over 2. So positive radical 2 over 2, negative radical 2 over 2. In the next one, positive radical 3 over 2, comma negative a half. So that is the unit circle. And I'm going to upload one of these for you that is completed. But this is how you complete it. Again, in the past, I've given students like 5 minutes and you got to fill out the whole thing. It seems like it would be hard, but most students actually get the hang of it relatively easy. So, all right. With that, there's a couple other things I need to tell you for our assignment. So these coordinate pairs correspond to trig functions. And when we actually do the problems, this will make a little bit more sense. But you might just want to make note of this here. Each of these coordinate pairs is an x and a y coordinate. These correspond to a cosine and a sine value. So the x position actually corresponds to the cosine of theta, and the y position corresponds to the sine of theta. That's going to be the extent of what you need to know for our first assignment. As we move forward, there is some more stuff you'll need to know. Like, for instance, the tangent of theta. I got it really thick there. The tangent of theta. If you know anything about trig functions, is the sine over the cosine. And if the sine is y and the cosine is x, then the tangent of theta is actually y over x. So to find the tangent of theta, you would just do the y coordinate over the x coordinate. So those are the biggies that you need to know for now. The version of this that I'm going to give you does have these written on there. But again, the x comma y corresponding to the cosine and the sine is the most important thing. I always just remember it as x comes first in the alphabet, and cosine, the c, comes before sine. So that's how I remember it. Cosine before sine, because x before y in the